Welcome to the lecture on problem solving on input modeling. So, we have studied few things about the input modeling. We have studied about the joint distribution variables. We have studied about the uniformity and independence. So, check. So, we have discussed many questions, and in this lecture we will discuss about different kinds of problems whatever we can, so that we have some more exposure to the problem solving. Dealing with the first question, where the x and y are jointly discrete random variables, and the pxy is defined as x plus y by 30 for x equal to 0, 1 and 2. So, you have discrete values of x as 0, 1, 2, and the y values are for 0, 1, 2 and 3, and pxy is 0 otherwise. So, we have to check that whether x and y are independent or not. For that, as we have understood that the condition is that pxy should be equal to pxx into pyy, and if that is coming, in that case x and y can be said to be independent, otherwise not. So, let us compute whether pxx is equal to pyy. So, in this case what we see is, so we have the question as pxy as x plus y upon 30, and x is 0, 1 and 2, and y is 0, 1, 2 and 3. So, these are the values, and it is 0 otherwise. Now, pxx we will find. So, pxx will be, it will be for all y pxy. So, that is for all y equal to 0 to 3, it will be x plus y upon 30. So, it will be x by 30 plus 0 plus x by 30 plus 1 plus x by 30. So, x plus 0 by 30 plus x plus 1 by 30 plus x plus 2 by 30 plus x plus 3 by 30. So, you have 4 terms, and that is why it will be 4x and then 1 plus 2 plus 3. So, 6 by 30. So, it will be equal to 2x plus 3 by 15. Now, we get pyy. Pyy will be summation for all x pxy. So, here you have the values of x as 0 to 2, you have discrete values 0, 1 and 2, and in that case you have x plus y by 30. So, it will be once 0, so it will be y plus 30 by y plus 1 by 30 plus y plus 2 by 30, 3 times, 3 terms will be added. So, it will be 3y plus 3 by 30. So, it will be y plus 1 by 10. Now, we find pxx into pyy. So, pxx into pyy, if we do the multiplication, it will be 2x plus 3 into y plus 1 by 15 into 10. So, it will be 2xy plus 3y plus 2x plus 3 by 150. So, what we see is this is not equal to x plus y by 30. It means pxx into pyy is not equal to pxy. So, x and y are not, so they are not you know they are not independent. So, this is how you solve this discrete distribution joint distribution function. Next question is that you have x and y as joint continuous random variables with f x y equal to y minus x for x varying from 0 to 1 and y varying from 1 to 2, and it is 0 otherwise. So, we have to see whether x and y are independent, and we have to compute E x variance x, E y variance y, covariance of x y and correlation x y. So, these things are to be computed. Now, so this question is, question 2 is f x y equal to y minus x is given for 0 to 1, for x as 0 to 1 and y is varying between 1 to 2. So, this y is varying between 1 to 2 and it is 0 otherwise. So, we have to find many parameters in that. Now, first of all we have to see whether it is dependent or independent. So, for that we have to find f x x and f y y, and then we have to see whether their multiplication is same as f x y. So, then we can say whether it is independent or not. So, it f x x it will be integral f x y and then it will be dy. So, y varying from 1 to 2. So, it will be y minus x dy integral and 1 to 2. So, it will be y square by 2 minus x y and then it will vary between 1 to 2. So, it will be, once we take 2 and 1 as this, so it will be 4 minus 1 3 by 2 minus x y. So, x y means x into y is 2 and then 1, 2 minus 1, so x. So, it will be 3 by 2 minus x, x is where, so f x x is 3 by 2 minus x and x is varying from 0 to 1. Then we have to find f y y. F y y will be for all dx, so integral dx we have to do and x varies from 0 to 1. So, this will be y minus x dx. It will be f x y dx and x is varying from 0 to 1. So, it will be y x minus x square by 2 and x is from 0 to x equal to 1. So, it will be, so for this it will be y minus and for this it will be 1 by 2. So, in this case, so f y y is we are getting as y minus 1 by 2, 1 to y is varying from 1 to 2. Now, for checking the independence, we have to see that f x x multiplied by f y y, it is coming as 3 by 2 minus x multiplied by y minus 1 by 2, and it is not coming as same as y minus x. So, this is not coming as similar to y minus x, that is f x y. So, x and y are said to be not independent. So, x and y are not independent. Now, we have to compute these values E x, variance x, E y, variance y, covariance x y and correlation x y. Now, we will compute the E x. E x is computed as integral x f x x dx. So, it will be x f x x we have computed as 3 by 2 minus x. So, x into 3 by 2 minus x dx, and it will be from x is varying from 0 to 1. So, it will be 3 by 2 x. So, 3 by 2 x square by 2 minus x square. So, x cube by 3, and x is varying from 0 to 1. So, it will be 3 by 4 minus 1 by 3. So, it will be 5 by 12. This is the value of expected value of x. Further, you have to calculate E x square. E x square is x square f x dx integral. So, it will be integral x square f x dx. So, this will be coming as integral x square into 3 by 2 minus x dx. So, it will be 3 by 2 x square. So, x cube by 3 minus x 4 x cube. So, x 4 by 4, and x is varying from 0 to 1. So, this value will be 1 by 2 minus this value will be 1 by 4. So, it will be 1 by 4. Next, you have variance x. Variance x will be e raised to the e x square minus e x square whole square. This is what the meaning of variance is. So, e x square we have computed as 1 by 4 minus e x whole square will be 5 by 12 square. So, it will be 25 by 144. So, it will be 36 minus 25 by 144, it will be 11 by 144. Then we have to compute E y. E y will be integral y f y y dy. So, it will be y is varying from 1 to 2. So, it will be 1 to 2 y into f y y is basically y minus 1 by 2 dy. So, it will be y square dy, that is y cube by 3 minus half y dy. So, half into y square by 2. So, y square by 4 in fact, and y is between 1 and 2. So, this value will be 8 minus 1 7 by 3 minus again y square by 4. So, 4 minus 1 3 by 4. So, this will be 19 upon 12. Now, next is E y square. E y square will be again integral 1 to 2 y square f y y dy. So, it will be again y square into y minus 1 by 2 dy 1 to 2. So, this will be equal to y cube dy. So, y 4 by 4 0 1 to 2 minus y square by 2 dy. So, y cube by 3 into 2 and this will be again 1 to 2. So, this will be 2 raised to the power 4, that is 16 minus 1 15 by 4 minus 2 raised to the power 3. So, 8 minus 1 7 by 6. So, it will be equal to 31 by 12. So, it will be basically 45 minus 21. So, this is nothing but this is 12 is here and you will get 45 minus this is 14. So, 45 minus 14 is 31 by 12. Next is you have to compute variance y. Variance y will be computed as again E y square minus E y whole square. So, it will be E of y square minus E y whole square. So, it will be 31 by 12 minus E y square. So, it will be 361 by 144. So, it will be 372 minus 361 by 144 11 by 144. Now, we have to find E x y. When we try to compute the covariance, in that case we need E x y. So, E x y will be integral x y f x y dx dy. So, you have double integral, x is varying from 0 to 1 and y is varying from 1 to 2. Now, in that case what we see is it will be x y into y minus x dx dy and double integral 0 to 1 and 1 to 2. So, first of all we will do for dy, and in that case this value will come as x y square. So, x y cube by 3 minus x square y. So, it will be x square y square by 2, y is varying from 1 to 2 and that value which will come again it will be integrated between 0 to 1 and then it will be dx. So, its value we will write there. So, this will be again. So, once we take 1 to 2, now taking y as 2. So, it will be 8 minus 1 7 x by 3. So, it will be 7 x by 3 because this y cube. So, 2 raised to the power 3 minus 1 raised to the power 3. So, 7 x by 3 minus again x square into y square. So, 2 raised to the power 2 minus 1 raised to the power 2. So, it is 3 x square by 2 and it will be dx and x is varying from 0 to 1. So, that will be again 7 x square by 2. So, it will be 2 into 3 6 minus 3 into 3 by 2 into x cube by 3. So, it will be x cube by 2 and then x is varying from 0 to 1. So, taking this it will be 7 by 6 minus 1 by 2. So, 7 by 6 minus 3 by 6, 4 by 6, that is 2 by 3. So, we have got EXY. So, EXY we have got as 2 by 3. Now, we have to find the covariance. So, covariance XY, it is defined as EXY minus EXEY. So, we have computed EX and EY earlier, and EX, so it will be EXY we have computed as 2 by 3, EX was computed as 5 by 12, and EY was computed as 19 by 12. So, 2 by 3 minus 95 by 144. So, it will be 96 minus 95 by 144, it is 1 by 144. So, once we get that, we can further get the value of correlation. So, correlation XY will be covariance XY divided by variance X into, I mean under root variance X into variance Y, or sigma X into sigma Y. So, this will be covariance XY divided by under root variance X variance Y. So, it will be 1 by 144 divided by under root variance X is 11 by 144 and variance Y is again also 11 by 144. So, it is 11 by 144 in the bottom, 1 by 144 into 144 by 11. So, it is 1 by 11. So, what we see that correlation value is coming out to be 1 by 11. So, all these parameters are calculated in this fashion. Next, the next question we will discuss. The next question is as it is shown that we have to test whether we show a series of numbers are given, and we have to test whether the 3rd, 8th, 13th and so on, the numbers in the following sequence, whether they are autocorrelated. So, here we have to see whether this third number, that is 0.23, after that a gap of 5. So, 3rd, then you have 18th, that is 0.28, then again 13th 0.33, then you have 18th, so that is 0.27, whether they are autocorrelated or not. So, we have to do the autocorrelation test for these numbers. Now, for that the test procedure is that you have to get the value. So, you have to start from 3rd, so I equal to 3, and you have to go at the interval of 5, and you have to see that when you get this number 30. So, basically an integer m, capital M is defined, where here m is 5, small m is 5. So, in this case, in the data, what we see is you have to start from the 3rd data and you have to go after the interval of 5. So, I is basically you are starting with 3 and you are going with the interval of 5. Now, total number of samples n is basically 30. So, capital M is to be defined, as we know the condition is that I plus m has to be less than equal to 30. You have basically 30 observations n. So, this is the condition, and if you put that, in that case this is 3. So, it will be 27 and by m, so it will be 5. So, m has to be less than equal to 4. So, m has to be 4. So, m is taken as 4. So, m being an integer, you have to take m value as 4. Now, as we know that we have to check the autocorrelation. So, in the autocorrelation, the row value that is it is defined as rho I m. So, rho I is 3 and m is small m is 5. So, this is defined as we have already discussed, it will be 1 by m plus 1 and summation of integral k equal to 0 to m r I plus k m and into r I plus k plus 1 into m. So, this way and then minus 0.25, this value you have to find first. So, this value once it is found, then you are finding the epsilon, that is sigma rho I m, and then this sigma rho I m, from there you get the z naught. So, that variate value you get, and that value has to be compared to the critical value from the table. Now, this value if you look at m is 4, so we have got 5. Now, we will start from k equal to 0, so it will be a random number of third position, so that is 0.23. So, 0.23 and then this is multiplied by I plus 5, 3 plus 0 plus 1, so 1 into 5. So, random number at 8th position. So, 0.23 multiplied by 8th position 0.28. Then further next time when x k is taken as 1. So, it will be number at 8th position and this will be at 13th position. So, 8th position is 0.28 and 13th position number is 0.33. So, similarly again 0.33 multiplied by again 18th position. So, it will be 0.27, it is 27 here. So, it will be 0.27. Then further 0.27 multiplied by, you see again that we go to next interval. So, it will be 0.05. And then again 0.05 multiplied by 0.36. This is the last number which we get in this, because after 0.36 we do not have any number after that left, and then we are subtracting it with 0.25. So, this value if you get, it is coming as minus of 0.1945. Now, once we go get this rho estimator for 3.5, then we get sigma rho 3.5. So, that is computed as we have seen a formula, that is 13 m plus 7 divided by 12 into m plus 1. So, it is 13 m plus 7, m is basically 4. So, it will be 13 into 4 plus 7, so 59, and its square root is something close to 7.7 and divided by this is 60. So, we are coming to be 0.128, and the z naught value is coming out to be rho I m estimator divided by sigma rho I m. So, this value is coming out to be now. So, that this value rho I m we have calculated 0.25, and this is so now this is value as 0.1945 minus divided by 0.128. So, minus 0.1945 divided by 0.128, and this is coming out to be minus of 1.516. Now, the condition is that this value should be in between minus z alpha by 2 to plus z alpha by 2. So, if this is in between them, you can take this, you cannot reject the null hypothesis of independence. If this value of z naught is in between this z alpha by 2 and minus z alpha by 2 and plus z alpha by 2, then you can say that you cannot reject this null hypothesis of independence. Now, this value is to be calculated, I mean this value is to be referred by looking at the table for alpha by 2. Now, alpha is taken as 0.05. So, you are having a 5% of the tolerance. So, once you go to alpha by 2 means it is 2.5%. So, 2.5% means it will be 97.5% is the value you have to look into. So, you go to this value in this table you see the 97.5 value. So, you see here in this case 97.5 will come in this, and we further goes, this is 1.95, 1.9 plus 0.05, so it is 1.95, 1.96 is coming out to be 0.975. Now, what I mean to say that this alpha by 2 basically is coming out to be 0.025. So, it is 2.5%. So, you have to go for, so tolerance is 2.5%. So, you have to go for 97.5%. So, you have to see the value of 0.975 from table. For what? So, this is for what z variate value. So, that will be z naught. Now, from this looking at this table, as we have seen, this 0.975 is for 1.96. So, this value is coming out to be 1.96. Now, this value basically is, now this is basically between minus 1.516. So, this value is z alpha by 2 basically. This z alpha by 2 basically is minus 1 point. So, this value will be minus 1.96 and this will be plus 1.96, and this value z naught, this is coming out to be minus 1.516. So, this is coming in between that. So, once this is coming in between that, we can say that using the null hypothesis we cannot reject the independence for this sample. So, we can say that the sample looks to be independent. Thank you.